All right, let's unpack this. Looks like we're diving into some intriguing chemistry factoids today, specifically something called thermoluminescence.
Yeah, it's pretty cool stuff.
From what I've seen, it's used for a ton of different things, measuring radiation, dating old pottery, even figuring out if food's been irradiated.
It really is quite versatile. At its core, thermoluminescence reveals a hidden history within materials. It's a story told by the light they release when heated.
Okay, before we get too far ahead of ourselves, what exactly is thermoluminescence? Lay it on me.
So picture a crystal lattice. You can think of it like a microscopic jungle gym for atoms. Now, when this lattice gets hit with radiation, some of that energy gets trapped, almost like tiny fireflies stuck in the structure.
Huh, okay.
Then when you heat the material up, that trapped energy is released as light. Boom, thermoluminescence.
So it's like these materials are soaking up energy from radiation, then spitting it back out as light when they get warm.
Precisely. And get this, the intensity of that light tells us a lot about the material's past, specifically how much radiation it's been exposed to over time.
Wow. It's like they've got a built-in radiation detector. One of the factoids you sent mentioned something called radiation dosimetry. What's that all about?
Right, dosimetry, it's basically just measuring radiation doses. And with thermoluminescence, we can actually figure out how much radiation someone's been exposed to.
And how is that helpful?
Oh, it's super important for people who work around radioactive material. Think nuclear energy or medicine. They wear these badges with thermoluminescent materials in them. Then, by analyzing the light given off, we can tell exactly how much radiation they've encountered.
So it's like a safety precaution, making sure people aren't being exposed to dangerous levels.
Exactly. It's absolutely crucial for protecting their health.
This is incredible. I never knew there was a way to actually measure something like that. Another factoid you sent talked about using thermoluminescence for archaeological dating. How does that work?
Now that was really fascinating. Say you have a piece of pottery. Pottery contains minerals that trap radiation energy over time, right?
Right.
So archaeologists eat the pottery up, measure the thermoluminescence, and boom, they can figure out how long ago it was fired.
So the older it is, the more radiation it's absorbed and the brighter it glows.
Basically. And it's not just pottery. It can be used to date all sorts of materials, geological formations, even teeth. It's like a window into the past.
That's wild. Okay, now I got to ask about the food irradiation thing. How can thermoluminescence tell us if our food's been, well, zapped with radiation?
Well, this application is all about figuring out if food's been irradiated, to kill bacteria or make it last longer. Some minerals in food, like those found in spices or, say, bone fragments in meat, give off thermoluminescence.
Hi.
By analyzing the light they emit, we can tell if the food's been irradiated or not.
It's like a food detective, revealing secret histories.
Exactly. It's a great tool for making sure our food is safe. And, being transparent about how it's been treated gives people choices.
Thermoluminescence is shaping up to be way more useful than I initially thought. Radiation dosimetry, archaeological dating, food safety, it does it all. What other applications are out there?
Well, one area that's really gaining traction is the study of meteorites.
Meteorites?
Yeah. So by analyzing the light emitted from these extraterrestrial rocks, scientists can actually learn a lot about them, their age, how much cosmic radiation they've been exposed to on their journey, even clues about the early solar system. It's like reading messages from space.
Whoa. Okay, meteorites. Now that's taken things to a whole new level.
It really is, and the applications are pretty much limitless. As researchers learn more, they're constantly finding new ways to use thermoluminescence. It's incredible what we can learn just from observing the natural world.
I am absolutely hooked. And we're just getting started. There's still so much more to unpack about thermoluminescence. Let's dive back in.
Sounds good to me. The deeper we go, the more fascinating it gets. All right, let's unpack those energy traps a bit more. Remember, they're kind of the key to this whole thermoluminescence thing.
Okay, yeah. Remind me exactly what those are again and how they, lead to that light we see.
Sure. So think back to those crystal lattices we talked about, the tiny jungle gyms for atoms.
I'm with you.
Well, sometimes those lattices have little imperfections, like maybe an atom is missing or there's an impurity, and those imperfections create what we call energy tracks.
Gotcha.
So when radiation hits the material, some of the electrons get bumped up to a higher energy level, but then they get stuck in those imperfections, trapped.
But they're like stuck in little pockets within the crystal.
Exactly. And they stay there, holding onto that extra energy until we apply heat. The heat gives them that little push they need to jump back down to their normal energy level. And when they do, bam, that energy gets released as light. Thermoluminescence.
It's like those electrons are little springs compressed by the radiation, and then when you heat them up, they release that stored energy as light.
I like that analogy. A great way to visualize it. It really highlights that principle of energy storage and release that's at the heart of thermoluminescence.
You mentioned different materials exhibit thermoluminescence. Does the type of material affect what color light comes out?
That's a great question. And yeah, it totally does. The specific color of light or wavelength depends on the energy difference between those trapped energy levels.
Huh.
So different materials, with their unique crystal structures and imperfections, will actually emit different colors when heated.
So each material has its own kind of signature glow. That's pretty neat. I wonder, can scientists use those different colors to, like, actually identify the materials?
You're on the right track. They totally can. Researchers can actually analyze the spectrum of light emitted during thermoluminescence to figure out what specific elements are in a sample.
Wow.
It's called thermoluminescence spectroscopy, and it's super helpful in fields like geology and materials science.
This is incredible. We've gone from measuring radiation to dating old stuff, checking our food, even identifying materials by their glow. What else can we learn from this thermoluminescence?
Well, one really interesting area is the study of environmental change.
Oh, like how?
So picture sediment cores, from lakes or the ocean. They accumulate over time, right?
Right.
And those layers trap minerals that have been exposed to sunlight and radiation. Well, by analyzing the thermoluminescence of those minerals, scientists can actually reconstruct past climate conditions.
Wait, hold on. How can glowing sediment tell us about the climate from, like, hundreds or thousands of years ago?
It's all about the intensity of the signal. See, the brighter the thermoluminescence, the more sunlight those minerals were exposed to back in the day. And that gives us clues about temperatures, rainfall, even volcanic eruptions. It's like reading the Earth's climate diary.
That's insane. So we're not just looking at the light itself, we're analyzing how bright it is to understand how the environment has changed over time.
Exactly. It's pretty powerful stuff. Helps us understand past environments, see how the climate has shifted over millennia. That's super important for predicting future trends and figuring out how to deal with climate change.
Wow, this just keeps getting more and more interesting. Ancient artifacts to meteorites to now the Earth climate history. The thermoluminescence is like this key unlocking secrets hidden right in front of us.
It really is, and it all comes back to that simple principle of light being released from materials when they're heated. It just goes to show, the power of observation and how connected everything really is.
I'm definitely starting to see that. And we haven't even talked about all the factoids you said over. There's still so much more to explore. What else is there to uncover about this amazing phenomenon?
Well, one of the more, I'd say, intriguing aspects is its potential in medical imaging. Researchers are actually exploring ways to use it to develop new, safer imaging techniques that use light instead of, say, ionizing radiation.
Wait, safer medical imaging? How does that even work?
The idea is to use nanoparticles that exhibit thermoluminescence, introduce them into the body, target them to specific tissues or organs, and then, boom, stimulate them with light to produce a signal. That signal can then be detected and used to create images, but without exposing the patient to harmful X-rays or other radiation.
So it's like using tiny glowing beacons inside the body to create images.
That's a great way to put it. Now, it's still early days in the research, but the potential benefits are huge. Imagine being able to diagnose and monitor diseases with incredible precision, but without the risks of traditional imaging.
This thermoluminescence is a total game changer. It's amazing to think how many different ways it's being used and the potential it has for the future.
And to think it all stems from that simple act of heating something up and watching it glow. It's a beautiful example of how scientific curiosity can lead to incredible discoveries.
I'm totally captivated. We've gone from archaeology to astronomy to medicine, all thanks to thermoluminescence. But we're not done yet, right? There's still a few more factoids to unpack.
You got it. There are actually some interesting challenges and practical considerations when it comes to thermoluminescence dating. It's not always as simple as it seems.
Oh, I bet there's more to it than meets the eye. All right, let's dive into those details. Okay, so let's talk about those challenges with thermoluminescence dating. You mentioned it's not always straightforward. What makes it so tricky sometimes?
Well, one of the biggest things is something called anomalous fading.
Anomalous fading.
Yeah. Basically, it means some materials can actually lose their trapped energy over time, even without being heated.
Oh, wow. So it's like those little fireflies escaping the crystal lattice before we can measure their light.
Exactly. And that can make the material seem younger than it really is, throwing off the dating accuracy.
That makes sense. So how do researchers deal with that?
Well, they have to be super careful about the materials they choose. They look for ones that have minimal anomalous fading. They also have to consider things like how the material's been treated over time. Was it exposed to a lot of sunlight, heat, moisture?
So it's not just about the material itself, but also like its whole history?
Exactly. It's all got to be taken into account. Thermoluminescence dating really requires you to think about a lot of different variables to make sure you're getting accurate results. It's not just, heat it up and read the light.
So it's like a detective piecing together clues. You got to consider everything that might have affected the evidence.
That's a great way to put it. And just like a detective, researchers have to be really careful about contamination, too.
Contamination?
Yeah, if a sample gets exposed to any extra radiation, it can really mess up the results, make it seem older or younger than it is.
So keeping those samples pristine is key, huh? Sounds like thermoluminescence dating is as much an art as it is a science.
You got it. It takes a lot of skill, attention to detail, and yeah, a bit of that detective work to really understand what these materials are telling us.
Well, this has been an absolutely fascinating deep dive. We've covered so much ground: radiation safety, archaeology, food science, even medicine. It's amazing to think how much we can learn just from heating things up and seeing what kind of light they give off. Who knew?
It really is remarkable. It shows you how powerful scientific curiosity can be and how connected everything in the natural world is. I mean, we went from ancient pottery to the Earth's climate to meteorites.
And even medical imaging. It's truly incredible. This deep dive has definitely sparked a newfound appreciation for, well, for the hidden wonders all around us.
Absolutely. There's always something new to discover.
That's for sure. And I bet our listeners are feeling inspired to learn even more. So until next time, keep those minds curious and don't be afraid to explore the world around you. You never know what amazing secrets you might uncover.